Alright, so to simplify really complex fractions, all you need to do is rewrite the division as multiplication and then multiply by the reciprocals. Okay, and that's when you have the really crazy ones, which we're obviously going to be getting into here as well. So something like this is a really complex one. So what we're going to do is we're just going to worry about the top for right now. Just worry about the top, and this is the top. So how can I get the top to have common denominators? So this has an x plus 3 in it, so I need to multiply this by an x plus 3 on both the top and the bottom. This has an a plus 3 in it, so I need to multiply this by an a plus 3 on both the top and the bottom. So by doing so, I have 2 times a plus 3 and 2 times x plus 3. So when I subtract them together and distribute, I get a 2a plus 3, or 2 times 3 is 6, so it's 2a plus 6, sorry, over a plus 3 and x plus 3. Over here, it's 2x, and it is plus 6, and that's a plus 3 and a minus, or a plus 3 and x plus 3. But this is minus, so when I combine them, it's actually minus whatever's on top, which means I have to distribute that through. So that's minus and minus. So when I distribute, I actually get 2a plus 6 minus 2x minus 6. Well, this 6 and this negative 6 cancel each other out. Leave me with a 2a minus 2x over x plus 3 and a plus 3. So I can take a 2 out of both those, and as you see right there, if I can move this all for you, this is what we're left with so far, but that's what we're left with on top. So that's what we're left with on top. That helps, but it also means we have a lot of work yet to do, because that's the top. And that's all divided by that, which means we can multiply that by the reciprocal, which is like saying take what we have times 1 over x minus a. So by doing that, when we combine together, this is what we have. Well, is there anything that we can take out? Well, these look really close, so you're probably thinking, well, let's just take them out. Well, you can and you can't. We can take them out if we can make them look the same. So how can I make them look the same? Well, the only way I can think of is if I take a negative 1 out of the top, right? If I take a negative 1 out, that leaves me with a negative a plus x. Well, how does that help? If I flip-flop those around, I'll end up with an x minus a when I flip-flop them around. And now, because I have an x minus a on both the top and the bottom, these two right here can cancel each other out, and all I have left is a negative 2 times x plus 3, or sorry, negative 2 over x plus 3 and a plus 3. So rationalizing a denominator, you cannot have a root sign on the bottom. That's very simple. Not allowed. Can't have a root sign on the bottom. No means no, and that means don't do it. You guys leave them there all the time, and it frustrates me when I tell you to simplify a problem and you see a root sign on the bottom. You know you aren't done. I'm telling you right now. So to do that, you got to multiply by the conjugate, and the conjugate is basically means the opposite sign, or the opposite radical. So it's something to keep in mind when we are rationalizing denominators here. So example 9. You can't have these roots in the bottom. So to get rid of those roots, it's actually very simple. You multiply both the top and the bottom by the conjugate. This is square root of x plus the square root of y. So the conjugate is the opposite. So it means multiply it by the square root of x minus the square root of y. That's it. So 1 times all that basically just gives me all that on top. This I need to FOIL. That's the problem. So root x times root x is just an x. So I have an x right there. Root x times negative root y, well, it's root xy, but it's negative, so I plug that in there. And root y and root x, same thing, but we got a negative there. I guess I just flip-flop those backwards. So they're negatives and they'll cancel out, and then root y times negative root y will give you negative y. Well, these cancel each other out. Root xy minus root xy, they cancel out, leaving you with root x minus root y over x minus y as your answer. Okay, so in calculus, you need to rationalize denominators. It's the truth. I'm not lying. However, sometimes you need to rationalize the numerator as well. So really, let's take a look here. If we have h and h cannot be 0, we need to rationalize the numerator. All this means is everything that you have, look how everything's the same except now multiplying it by the positive, right? The conjugate there. So when we do this, the bottom very simply is h times all that, but now we need to FOIL. Root x plus h times root x plus h means the roots cancel out, leaving you with just x plus h. So we have that on top. Then root x plus h times a positive root x will cancel out, which is why I jumped the gun to the last term eventually. So you're left with a negative x. And the reason why I just did that is because, like I said, this times this will be a root x squared plus h, and this times that will be a negative root x squared plus h. So they'll just end up canceling out anyway. Then on the bottom, it's h times all of that. So it's h times root x plus h times root x. So we need to get things to cancel out. These x's cancel out on top, leaving you with h over h times root x plus h times root x. These h's, there's an h in everything. Since there's an h in everything, we can take that h out of everything, leaving us with 1 over root x plus h plus root x.
My baloney has a first name. My baloney has a first name.
Alright, so we'll have to continue when we come back with prereq 7 in Algebra 3 Trig.